Okay, this is a problem out of section 11.2 in my math lab, and it's a piecewise function that asks us to graph the function and then find all the y values where the function is discontinuous, and then find the limit from the left and the right at any values where the function is, in fact, discontinuous. So for the first one, the correct answer is already checked. And the reason that this is the correct graph rather than the graph right next to it on the left is because at the value x equals 0, we have 2x plus 3, and if x is equal to 0, then we have 2 times 0 plus 3, and that equals 3. And if we use the rule x squared minus 4x plus 3, that gives us 0 squared minus 4 times 0 plus 3, which also gives us 3. And that tells us that at x equals 0, the y value is in fact 3. So for that reason, then, this graph is continuous at the only suspicious point, which is x equals 0. It's continuous for all x values equal to or less than 0 because that follows a linear rule, 2x plus 3. There's no chance of dividing by 0 or taking square roots of a negative number. And in x squared minus 4x plus 3, that is also continuous for all positive x values, because we're, again, not going to divide by 0, and we're not going to be required to take any square roots. So for that reason, the function is never discontinuous, and the correct answer is the function is continuous for all values of x. And then because of that, then part C, we don't need to find the limit from the right and left because the function is continuous for all values of x.